Last week, we started looking at nature's unifying patterns in detail. We looked at five of these patterns and tried to understand them a little better. What do they mean? What do they imply? These 10 patterns, as you know, are the essential lessons from nature as far as design is concerned. And by looking at these patterns, by imbibing these patterns, we can start designing like nature. Again, these patterns are not just for biomimicry. Of course, they are a useful lesson in biomimicry, but they can also be used by anyone who is willing to incorporate these in their life and work in order to in order to make something more sustainable, in order to build sustainable solutions and also bring sustainability into their lives. So we saw nature uses only the energy it needs, which means that organisms use low energy processes. They don't try to use more energy in order to get energy. And all of nature's energy sources are freely available, which means that you don't have to mine them. They are available locally and readily. Nature recycles all materials. We spoke about how upcycling is very accurate to describe what happens in nature. The log that falls on a forest floor, how that is broken down into components by organisms like fungi, which is then used up by other organisms, and so on and so forth. So nature recycles all materials. It's an important lesson for us in all of the things that we do, all the things that human solutions do. Nature is resilient to disturbances. Nature has a very uncanny ability to recover from any tough conditions, from difficult conditions, using four enabling mechanisms, namely, namely diversity, redundancy, decentralization, self renewal, and self repair. So that's what makes nature resilient to disturbances. Nature also tends to optimize rather than maximize. There's always a balance between the resources used and the resources expended. So that's something that nature does all the time. All life forms, all organisms actually end up doing that. And nature provides mutual benefit. In all of nature, you will see these cooperative relationships that work in order to provide benefits to all the parties involved, to all the life forms involved. And even if they are not cooperative, they actually work well in the system context. We saw that already. Now let's move on to the next set of patterns. As mentioned earlier, they are not in any specific order. These 10 patterns are not in a specific order. All of them are equally important, equally relevant. So nature runs on information. Before we start looking at this, also try and connect this to what you learned about systems thinking. In systems thinking, you learned that there is a interconnectedness. There are relationships that exist between all of, I mean, all systems, of course. Try and apply that in the context of the nature's unifying patterns as well, and you will start seeing the connections. I mean, clearly, right now, if once you start hearing about nature runs on information, you will immediately start making connections to the other patterns that you've already seen. Out here, the patterns that you've already looked at, you can start looking at connections between them. Nature is resilient to disturbances. Nature tends to optimize rather than maximize. There is a connection that you can see now. There are, of course, other connections that you can start making as well. So instead of looking at each of these as individual patterns, individual lessons that you need to learn, also start looking at the connections between them and how they work together in order to help us live sustainability and create more sustainable solutions. So let's come back to nature runs on information. What does that imply? All of nature, for survival of any life form or any living system, they need to receive information from the environment, and act on that information appropriately. Now, this is something that sounds very obvious, but it's an important lesson to learn, because the the act of sending, receiving, and responding to signals is actually a evolutionary capability that has been fine tuned for several millions of years. Some organisms have a very narrow range of optimal conditions in which they can function. So therefore, it's very critical for them. It's very critical for those living systems to keep monitoring the environment in order to ensure that they are able to survive appropriately. Other organisms still have a broad range, but they need to make sure that those conditions are not actually approaching the limits, whether it is something like availability of oxygen or whether it is the maximum survivable temperature. Organisms and living systems constantly need to monitor the environment to ensure that they are the optimal conditions are available to them, and if not, what do they need to do, how do they need to respond to those conditions. So this kind of feedback loops are critical for organisms survival. I think this is something that you would have observed even by looking at nature generally. And these feedback loops are available not just between the organism and the environment external to it. Even within the organism's own body, within a cell, you will actually see these kind of feedback loops where some conditions are constantly monitored, and the organism keeps receiving information and acts on that information accordingly. Now, these feedback loops could also be positive feedback loops or negative feedback loops. Positive feedback loops are loops where a process is speeded up based on the information received. A negative feedback loop is when the process is delayed based on the information received. So, this kind of mechanism exists in all of nature, in all life forms, in all living systems, and critical to the survival of the living system as a whole. And that's what is means it means when we say nature runs on information. Information is a one kind of critical resource. So one example of nature running on information would be the wood wide web, a fascinating phenomenon briefly explained in this video, the link to which you see on screen here. The link is also posted below the recording, so you can stop this recording and actually look at the video. It's not a very long video. It'll give you a quick sense of what it is. The Wood Wide Web, just like the World Wide Web, is a complex network, but this network is not of fiber cables, optic cables, etc. This is a network of fungi and bacteria that links trees together. So, under our ground, there is this extremely complex network. These fungi and bacteria grow around the roots of trees and create this network which not just swaps nutrients between trees. So the trees actually send nutrients to each other, especially the older trees send nutrients to the younger trees, the younger plants. They also exchange other types of information. So if one plant or a tree is under attack by pests, it sends chemical signals to the rest of the network saying that, hey, I'm under attack. So the other plants can raise their defenses. Similarly, if there is a plant that is deceased, a plant that is a tree that is diseased, not deceased, diseased, it sends chemical signals to the rest of the network saying that it's got some sort of disease, and it can also dump all its nutrients into the network so that other organisms, other plants can actually pick up those nutrients. So that's the Wood Wide Web, very close to the way our internet functions, and something that we don't even realize because it's under our feet, under the ground. So do look at the video and try and learn more about it, not just from the video but from other sources as well. A fascinating example of how nature runs on information. An example from the human world is this system created by a company called Regen Energy. Now, there's a there's a pretty comprehensive case study on what regen energy has done. They have used something called swarm energy management based on what bees do in order to create that system. But briefly, I'm going to tell you about it here. What they have created is a decentralized network of appliances within a building. Now, these appliances talk to each other to ensure that the collective power consumption of the appliances is kept to a optimal level. So instead of using a top down approach where each appliance talks to a server, they talk to each other. They determine how to optimize the amount of energy that they use in order to keep the energy consumption peak loads at a optimal level. Now, this is not just about nature running on information. This is not just a lesson, taking the lesson on nature running on information. You can clearly see the connections to the other patterns as well. I urge you to start looking at this, start looking at the connections between all the patterns, and you will start seeing the kind of, the kind of insights and perspectives that you start getting when you start looking at these patterns holistically rather than as individual patterns. Next, let's look at nature uses chemistry and materials that are safe for living beings. Now, all of nature's chemistry is water based, not based on any other uh, compound or chemical. It is all water based. And a key reason for that is all of life's processes happen within or near the cells of the organism. So, therefore, it makes sense that the organism ensures that the chemicals that are used, the processes that are used, and the materials that are used are all conducive to life. It just makes sense, right? Otherwise, it's going to be toxic. It's going to be something that's not going to uh, create conditions conducive to life. So, therefore, most of nature's chemistry is water based, and how that is accomplished is through chemicals that have very precise 3D structures. And what this ensures is that they are easily able to create these building blocks that can assemble on their own, and they are able to guide chemical activity that is required for life's processes. And also, the performance of these materials is enhanced because of the specific 3D structures that happened in nature. The best part is also because of these 3D structures, what happens once the job is done, once these chemicals have accomplished what they need to do, they are also degraded harmlessly without creating any sort of toxic waste which is harmful to the organism or its cells or other parts of the environment. And that's what nature does in terms of the chemicals that it uses and the processes that it uses. Clearly, this is a very important lesson for human solutions and human processes, because whether it is growing materials or sourcing materials or transporting materials or manufacturing materials, we clearly need to take this lesson from nature and use chemistry and materials that are safe for life. Because right now we know that we are struggling with toxic, non biodegradable materials that are creating more problems than they solve. And this is a lesson that can help us overcome that. An example of nature using safe chemistry from nature would be that 118 elements in the periodic table, and you can this pyramid here actually shows how many of those are found in all living systems and in all organisms. Of all these 118 elements, only 28 are found in nature's chemistry. And of those 28, 11 are only found in all organisms. The four of those 11, carbon, hydrogen, nitrogen, and oxygen, are the most abundant elements in on Earth, and they are found in all organisms. So this is these elements are found in slightly lesser amounts, and progressively in lower amounts in not all organisms. So nature's chemistry is based on elements that are found abundantly, elements that are safe and these are the elements that are used in all of nature's chemistry. And the fascinating fact here is that DNA, now DNA, as you know, is the genetic blueprint for all of life on Earth. DNA contains only five elements: carbon, hydrogen, nitrogen, oxygen, and phosphorus. And these five atoms come together in unique ways, are structurally arranged in unique ways in order to encode all life forms on Earth. Think about how stupendous that is as an achievement. And that's what the lesson is, that nature accomplishes stupendous things, wonderful things, and still uses chemistry and materials that are safe for living beings. Unlike human solutions, which tend to be toxic and non biodegradable, and we think that we are doing it because we need to accomplish something very important or very difficult. Nature does the same thing without having any toxicity involved. And that's the lesson we need to take here. An application in the human world of using safe chemistry would be natural products. Now, natural products, I mean products here which are genuinely natural products, because there are several products that have just a label which says they are natural, all natural, herbal, etc. We are not talking about those products. We are talking about products that are genuinely natural, which means what do they do? They use a small number of natural ingredients, just like what nature does. They use natural raw materials and pigments with minimal processing. And that's how they become safe for living beings. Therefore, they are also biodegradable, they are non toxic, etc. Because they try to mimic what nature does in terms of chemistry, in terms of processing, and that's how they end up being uh, equally safe, if not more, for human beings as well. So that's an example from the human world of using safe chemistry. Again, you will start seeing clear connections between this pattern and other patterns that you've already looked at and the patterns that we are going to look at. We urge you to start looking at those connections as well, because that will be key for you to understand these patterns better, find out how you can use them in the work that you do, in the solutions that you create. Next, let's look at this pattern of nature building using abundant resources and incorporating rare resources only sparingly. What this pattern implies is that all living systems, all organisms, look only for widely available and easily available resources in order to build things. Now, whether it is building something that is external to the organism, like their nest, like a termite mound or the nest, or any sort of home that they build, or incorporating materials as part of their own body, all organisms will look only for widely available materials. And even those widely available materials are those that are abundantly available on Earth. We already saw in the safe chemistry pattern carbon, hydrogen, nitrogen, oxygen. These are the most abundantly available elements on Earth, and organisms use these abundant materials fully. See, in the natural world, what is abundant is considered gold and therefore used to the fullest extent possible. Whereas in it's only in the human solutions and in the human world that we don't consider what is abundant as gold. We consider what is rare as gold and go after that. Nowhere will you find in the natural world that an organism travels millions of kilometers in order to source things like marble and granite and build their own house, right? Only humans do that. Whereas organisms in living systems, they use only abundant resources, and even rare resources are those which are readily available in the local environment, not traveling millions of miles in order to procure it, or shipping it or extracting it from the earth. That doesn't happen in nature. An example of this in the natural world would be the caddisfly. Now, the caddisfly is an insect that lives in the water, and the larva of the caddisfly builds these casings in which it lives to protect itself from predators. So this casing, I mean, you don't even know that this is a caddisfly, right? It just looks like a piece of rock. So it builds this casing using small pebbles, pieces of rock, and shells and twigs, etc. And it extracts a type of silk to hold all of it together. There is a video that you can watch to see how this actually happens, how the caddisfly actually does it. You can, the link to this video is actually posted below, uh, is actually posted below the this recording as well. So this is what the caddisfly does. It does not start looking for materials that are not available to itself. It does not spend energy looking for materials that are rare. It looks for materials that are available in its local environment because it lives in the water. It looks for materials that are available easily in the flowing water and creates this casing out of it to protect itself. And and because it is made of local material, it also blends in completely. So, and it protects itself from predators as well. So that's what the caddisfly does, an excellent example of using resources that are abundantly available, readily available in its own environment, and not looking for rare resources. An example from the human world for this would be these these homes that you see mostly in rural areas. So they use sun-dried bricks that are made of local sand, straw, clay, etc. Now these don't require a whole lot of sand to be mined from river quarries, etc. So using abundant resources is a lesson that these homes readily take. And the best part is that these homes are inexpensive, it- cheap to build, they are durable, they last in the environment that they are built for, and also in many cases they are energy efficient as well because they are built with materials that are from the local environment. So that's an example of using abundant resources in the human world. Next, let's look at a pattern which states that nature is locally attuned and responsive. Now, again, I'm going to reiterate that you must try and look for the connections between this pattern and the other patterns that you have seen. I'm not going to, spend too much time on that, but I'm going to urge you to start looking at that on your own. What does this pattern imply? The pattern implies that any living system, there are a few conditions that enhance its chances of survival. And what are these conditions? One is when they are good at recognizing local conditions and opportunities. Another is when they are good at locating and managing available resources. And the third is responding appropriately to the information that comes from the local environment. Clearly, you can see the connection between nature using energy, nature using resources, nature running on information. So, these are essential conditions for survival. And these come together in order to create this very important principle of being locally attuned and responsive. In any location in nature, you will find that living systems and the organisms that inhabit that have evolved based on the local environment conditions. Some of these conditions may be cyclical in nature, for example, tides or the seasons, etc. So, what these organisms do is they take advantage of those cycles and accordingly uh, uh, tune their life processes to that. So you have organisms that live in high moisture areas. They thrive in those high moisture areas. Whenever the tides come in and out, they live in those regions. Also, there could be some slower changes that happen, and at the same time, organisms adapt to those slower changes as well. So that is nature being locally attuned and responsive. And this is kind of an aggregation of some of the other patterns that you have seen earlier. An example of nature being locally attuned would be the plants that you see in the deserts, especially in Chile's Atacama Desert. Now, you have these plants that don't have very great water conservation strategies, but when it rains, and it rains, once in 5 years, imagine they go through long periods of drought. But when it rains, these plants ensure that they respond quickly. What do? They sacrifice water during these periods to produce large leaves that capture more sunlight so that they can grow rapidly, and they can grow flowers quickly so that this can help them reproduce, this can help them spread as well. So in the brief window of water availability, they ensure that all of their reproduction is actually happening. And during the dry spells, they don't attempt to do anything at all. The seeds don't attempt to sprout, they just remain dormant. So they don't spend unnecessary energy in trying to sprout during the dry spells. And that is an example of being locally attuned and responsive. An example of nature being locally attuned and responsive, a lesson from using the lesson of that in the human world, would be this project called Jeevan Bindi, or the life-saving dot. The bindi, of course, is this small little dot that most Indian women place on their foreheads. It's generally used to enhance appearance. Now, the the background to this project is that iodine deficiency is a widespread problem among women in India, especially rural women. And these rural women can also not afford iodine supplements. And because of that, the deficiency of iodine causes a lot of medical issues for these women. The local health centers and doctors do give them supplements to take in oral form, but these women are not used to taking these supplements, and therefore it doesn't really have much of an effect. So there was this agency, there was this organization that looked at this problem. They also found out that iodine can be absorbed through the skin. Therefore, they created the iodine patch. But instead of a patch that can just be placed anywhere on the skin, they created it in the form of this bindi. It's an iodine patch which is also a bindi, and they distributed it to all rural women across the country, in many parts of the country in India. And this was able to solve the problem of iodine deficiency among many women because they got the required dosage of iodine through this bindi that they wear. A clear example of understanding the local conditions and taking the lesson of being locally attuned and responsive to local conditions. This brings us to the last pattern on this list, which is nature uses shape to determine functionality. This pattern implies that any shape in nature, there is always a functional reason behind it. Nature is not using materials, is not using energy to come to a shape merely because it can. The reason that it is doing it is because it uses the form as a reason to accomplish a function. So instead of just adding energy and materials in order to meet a functional requirement, in nature, you will see that it uses form to meet the functional requirement. And this is in quite a contrast to many human solutions, right? We keep adding additional materials, additional energy just because we can in order to accomplish a function, but that's not what nature does. And the benefit of doing this for nature is that a minimum amount of resources are actually used in order to accomplish that function. So nature using form in order to determine function is an important lesson that human solutions can also take, because this ensures that the usage of resources is actually optimized. An example from nature of using shape for functionality is the Venus flytrap. Now, this video actually explains how the Venus flytrap uses shape to determine functionality. The link is posted below the recording, so you can pause it and actually look at it. Now, the Venus flytrap feeds on small insects and flies, and how it does that is through the shape of the leaf that you see. It's very unusual shape, and this unusual shape is not there just for aesthetic reasons. Now, what happens is this cup shape is very sensitive. So when an insect comes and sits on it, it actually snaps shut and captures the insect inside this cup cavity. At the same time, it's extremely sensitive as well, because even if it knows how to distinguish between an insect and any other thing like a raindrop. And these little hairs that you see along the sides of the leaf are sensitive to pressure. So when an insect comes and disturbs it, the it waits to see whether it's actually an insect or something else. And based on that, it snaps shut and captures the insect within the cavity. So do watch this video. You will be able to see how exactly this mechanism works and how the plant has been able to use shape to determine functionality. An example of the same thing in the human world is, of course, the Shinkansen bullet train. You have been introduced to this example earlier as well. The nose cone of the bullet train is actually modeled on the kingfisher's beak. So this bullet train earlier used to have a more rounded shape, which is why it was called the bullet train. And unfortunately, when it was passing through tunnels and exiting tunnels, it used to create this huge booming sound, which was causing a lot of noise pollution. People living next to the train tracks used to complain about the noise. Therefore, the engineers looked to nature and found that the kingfisher, when it dives into the water to catch fish, it it does not make a splash at all. So they use the same principle of moving from one medium to another without creating too much disturbance for the purposes of the bullet train as well, and modeled the front of the bullet train, modeled the nose cone of the bullet train after the shape of the kingfisher's beak, thereby taking the lesson of nature that shape is used to determine functionality. So these are the 10 patterns, unifying patterns of nature that we have looked at, all of them fascinating in their own right, all of them giving us valuable lessons and how we can incorporate them in our life and in our work. And also, all of them connected to each other in many ways, because by doing one pattern, you can actually bring in aspects of another pattern as well. So please do look at these patterns holistically. Look at the interconnections and the relationships between the patterns, of how one pattern can actually help you accomplish other aspects of other patterns as well. And try and see how you can imbibe them in your solutions, how you can imbibe them in your work.